Hello everyone, till now you have learned some concepts relating to generating functions and partial fractions. Now in this session you will be learning some more topics of unit 4. Firstly, let me introduce myself. Myself A. Ritika Reddy, working as an assistant professor in Vignyan's Institute of Information and Technology, Visakhapatnam. So in today's session you will be learning about calculating coefficient of generating function. So what is this coefficient? See guys, if there is a variable like 2x power 4, then this 2 is called as the coefficient, or there is a variable like x cube, then here though anything is not visible for you, actually 1 is present over here. So in this case 1 is the coefficient. So for our generating functions, we are going to learn how to calculate the coefficient of any particular term. For suppose we are asked to calculate the coefficient of x power 16 or x power 26 in a particular expression, then it is very difficult for us to expand each and every term and calculate the coefficient. So through this method, it will be very easy for you to calculate the coefficient of any particular term of the particular generating function. So briefly, generating functions are nothing but the functions which are of the form x square plus x cube plus so on to raised to some power n. So this is the form of generating function, and it can short written as sigma of x square given some condition over here. So this is the generating function. So coefficient can be calculated. This is the steps of calculating the coefficient. Coefficient can be calculated by reducing a given generating function to simple binomial type generating function or a product of binomial types generating function. That means, what is this binomial type generating function? For suppose here I am given x plus x square plus so on up to something x power something n or to the power of n, something I am given in this step. Here these are so many variables are there for us. It is very difficult to calculate from this expression. So what we will do? We will reduce this expression to a binomial type generating function. So what is this binomial? In our binomial theorem we have learned, right? Binomial means having two terms as the variable part. That means like x plus x square whole to the power of n. We are reducing this big expression to some this expression, and from this expression we will be calculating our coefficient. So calculating from this will be equal to calculating from this. The whatever output you will be getting will be same, because this is reduced to this one, or you can also reduce this as product of the binomial terms like x plus y into z plus x, something of this form. You can either reduce to single binomial expression or you can reduce to product of any two binomial expressions. Okay. So guys, these are the different types of polynomial expansions you will be encountering. These are like the basics. Okay. From this basics part only you will be get to know how to expand anything. If you observe this one over here, this is our normal generating function series. Like in our previous class I have said like 1 comma 1 comma 1 comma 1 comma and so on. This is the generating series, and this is the generating function for this generating series, and this is the closed formula which is obtained from this generating function. So similarly these all are there, and these if you observe, these are nothing but our binomial theorem expansions. About these you have seen in our previous session of binomial theorem. So here one more thing is there. If the generating functions are expressed as the product, then how to we need to find? Here h of x can be calculated by clubbing the coefficients of f of x and h of x in the manner which is showed over here. Okay. These are very basic binomial expansions. So please try to remember these ones. And next, if you see this example, you will be getting familiarized with what is actually the coefficient of the generating function. See, here I am asked to find the coefficient of x power 16 in this given expansion. So how to calculate this one? So what we will do? We will be reducing to the binomial terms in order to calculate. So how we will be reducing? We can reduce this one like, first we will take x square as common from this term. And how if I will take x square as common, then how I can write 1 plus x square plus so on, and this raised to the power of 5. Why I have taken x square as common? Why not as x cube as common? Because from the polynomial expansion, I have said like 1 by 1 minus x is equal to 1 plus x square plus so on. This is the standard formula. So we reduced into this type. So how this can be written 5 further? This 5 will be distributed to this x square, because a power m whole power n will be equal to a power mn. So it will be equal to 2 into 5, that is equal to 10. Okay, this part is over. So this 1 plus x square plus so on can be expressed like 1 by 1 minus x, right? So 1 by 1 minus x whole to the power of 5. So how this can be reduced? X power 10 into 1 minus x whole to the power of minus 5. Okay, that means as for this fraction power 5 is there, what we are doing, we are bringing that up, and that means we are inversing that one. So that's why I am inserting this negative sign over here. So now so this is written like x power 10 1 minus x whole to the power of minus 5. So calculating x power 16 in this term is equal to calculating in this term. So how this 1 minus x whole to the power of minus 5 is there? Now if you observe over here already x power 10 is there. And from this what we need to get? We need to get the coefficient of x power 6 only, because x power 10 into x power 6, what you will be getting? X power 16 only, right? So if you calculate the x power 6 in this term, as here only 1 is there, so whatever coefficient you will be generating for this x power 6, that coefficient only is for the x power 16. Okay. So how to calculate this from? If you see the formula over here, if you observe, see, this is the standard formula for calculating this 1 by 1 minus x whole to the power of n. See, this is the standard formula. So how to write this one? See, I will be showing how to write. See, here r, in the place of r, we need to substitute 6, and in the place of n, we need to substitute 5, because the entire is raised to the power of 5, right? And minus 1 as it is, and here also we need to substitute 6. So how I will be writing now this term? So this 1 minus x whole to the power of minus 5, in this if I want to calculate the coefficient of x power 6, then how I will be writing? 6 plus 5 minus 1, 6 x power 6. From the formula of the polynomial expansion, this I have written. So how this can be written? 10, 6, x power 6. What is this 10, 6 means? It means 10c6, x power 6. So if you calculate this 10c6, you will be getting a number, right? And that will be equal to the coefficient of x power 16. So 10c6 is the coefficient of x power 16, because here x power 10 is there for us, and for x power 10 there is only 1 is the coefficient. Na? So 10c6 is there, is the coefficient of x power 16 as a whole. So this is the example of knowing the coefficient of the any term in a given generating function. The generating function might be any big, no problem. It can be raised to the power of 20 also, and you are asked to find x power 22 value also. No problem. You can easily calculate. First what you will do, you will be reducing to any binomial term or any product of any two binomial terms. Later you will be checking from any other, our standard formulas are there, na? From that formulas whether you can derive anything. definitely you can derive, and after getting that you need to just substitute that values according to that and change the equation, and from that equation you can easily generate the coefficient. Okay. And this is the assignment question for you, and I am given a term in this way and the entire term is raised to the power of 6. I am asked to find the power of x coefficient of x power 10, very much similar to our problem. So, try to solve this one. Okay. And in this session you have learned until the calculating coefficient of generating functions, and you have seen an example and assignment question. Very, very important, because coefficient, if you will get to know the process of calculating, then solving in exams will be very time easy for you. Okay. Thank you. సరే ఆపండి, మళ్ళీ ఇంకో సెషన్ స్టార్ట్ పెడతాను.